So whenever we were trying to come up with an idea, we thought, what better thing to do in mechanical engineering than a manual transmission? And so we looked at several different styles, and this style in particular is modeled similar to a one for a lathe. Hold on. So we ran into some problems with our assembly because with our shifter mechanism that we have, it actually sits on a ball here that has the screw that goes through, and so we weren't able to set the limitations on the rotation around the vertical axis here. And then same with this ball that fits inside the shift forks. It actually transfers from surface to surface and then is able to move back and forth. So we weren't able to make an assembly that works, that you could actually show for shifting gears. But so we have the input, and then we have an output, which is our fan that shows how it works. And I designed the shift box, so I'll talk about that. So for the shift box, we engraved the gear number on the top, and then made the H pattern here, which is what the shifter will follow along while you're in order to shift between each gear. And then it has this ball at the bottom which fits in the shift forks that you saw in the assembly. And then we just left it open at the top so that we could mount some type of a ball, or in our final model case we mounted a cork. And I'll let Graham talk about the fan output that he designed.
Okay, so for sort of an erector set type toy, we quickly learned that we had limitations on volume. If you look at our gears, there's holes everywhere. We've trimmed anything we possibly can. And for the fan in particular, it is our most complex part. Because we designed it from the ground up parametrically, we were able to modify it quite easily to trim the volume down. We cut the volume down in half, actually. One of the things we did was the actual diameter of the fan blades is about an inch larger. We played around with the numbering of the fan blades, which is a simple pattern. Fan blades themselves are a variable section sweep, some nice rounds on them. We even played with the idea of going ahead and engraving Purdue on the fan blade. We ended up not doing that, but we did put our initials around here on the back, which what we didn't realize was how visible they'd be through the SLA, and we should have mirrored them so that they'd be legible from the front, because right now they're actually legible from the back. It was sort of just an Easter egg. Also, a really cool thing that I'd never done in PTC before was actually switch into polar coordinates to make this spiral pattern, which is a series of sweeps, sweep cuts. I actually used equations in polar coordinates to make those spirals, which constrained the sweeps. So all in all, we were also surprised how thin we could make the material but still retain rigidity, which was excellent, since our model needs rigidity to function. We can't have gears that just flop.
Yeah, that was one of our main concerns, was since the style of transmission, we don't have anything that actually transitions for engaging the gears, is that whenever you're shifting, you're pretty much just grinding the gears together until they engage.
Yeah.
So you're putting a lot of load on the gears, and we wanted to make sure that we were going to have good tooth thickness and the width of the gears so that they wouldn't bend or break.
It's also why our actual number of gear teeth is so small. And there are no dog teeth. Even these little itty bitty gears have tiny little holes in to reduce volume and to help drain the fluid.
Garrett, you want to talk about that?
Sure. So one of the most difficult parts of this project was getting everything to fit together and actually work together. You might have seen me kind of futzing with it a little bit just before this presentation, trying to get in first. Turns out first and second gear are kind of difficult to shift into, but once you're in there, it actually works pretty well, and you can sit here and spin the crank, and it's actually kind of cool because you can see
two gear sets.
right now I'm in first gear, and you turn the crank a whole bunch of times, and the fan barely moves. So you go ahead and there we go. Second gear, hit that, and oh, check it out. Fan's spinning a little faster. Come on over, and it actually shifts much more smoothly than we thought it would. It goes into third and fourth, no problem. And you can see that's a 1-to-1 gear ratio. Come out, going fourth, and then you have overdrive. So that's pretty cool. But one of the most difficult things was just getting everything to line up. And even now, like I said, first and second gear are they're just difficult to move. But we also had a lot of binding with our shifting mechanism. We've got these two shift levers that kind of wrap around a pair of gears for first and second, third and fourth, a cluster. And we had a lot of problems getting those to fit and actually move freely. They'd fit. You could clamp them together, you could bolt them together, and you could spin them with your hand if you really kind of tried and finessed it. I mean, you don't want to break anything, because it's one of those things where it's like if you break it, you're done. But we talked to someone who's actually pretty familiar with the SLA material, and we did a little research online, and we found out that you could use a silicone lubricant. Actually worked pretty darn well, and it actually works pretty darn well. We actually have great lubrication right at these two clusters, and that's really where we needed it most. The SLA material interfacing with the acrylic, there isn't too much friction there. That's pretty easy to move. But overall, I know at least I'm personally pretty happy with it. I'm actually kind of surprised it works as well as it does.
Talk about tolerancing a little bit.
But yeah, tolerancing was one of the most difficult issues that we had when putting this together. We bought some 1/4-inch square shaft. We didn't want to buy spline shaft because we figured we'd have itty-bitty little splines, and the first thing to fail would be those little itty-bitty teeth on the splines as opposed to the gear teeth themselves. So we bought essentially a 4-spline shaft. It's just a square shaft, and it works out pretty darn well. But it's actually a little bit less than 0.25. It's about 0.247, and we actually designed all of our square holes to be 0.25. So we've got 30 thousandths, plus or minus 15, and even then, every single square hole was undersized. And the most difficult thing about that was getting a really tiny file in that square hole and keeping that hole square, or square enough. But that worked, and we had issues with our shifter mechanism. You've got a cylinder going through a round hole, but some of them were printed sideways and some of them were printed, I guess, horizontal and vertical. So when you bring them together, you'd have a whole bunch of little ridges going against a whole bunch of little perpendicular ridges, and that created a lot of friction, and you had some non-circularity. But careful sanding fixed that.
Okay, thank you.